This is problem 99, and it is similar to problem 89, which we already looked at together. So for this problem, also, I would like you to try and get started on this on your own. So read through the problem. You have r as a function of z. I would like you to find r dot and r double dot. You have theta as a function of z. They give you theta dot, and they say it's always maintained, which means theta double dot should be equal to 0. And then we have z dot and z double dot. And I would like you to try and find everything that we have there. First, you can just worry about taking the derivatives, and if it helps to do things in 2 steps after you have taken the derivatives to find everything that you need here, then you can go ahead and evaluate what these quantities would be when z is equal to 6 meters. So you can go ahead and pause the video and do that now. Okay, so we have r is equal to 3/4 z, so r dot is equal to 3/4 times z dot, and r double dot is equal to 3/4 times z double dot. We have theta is equal to negative 1.5 z, so theta dot is equal to negative 1.5 times z dot, and theta double dot is equal to negative 1.5 times z double dot. But we know that theta dot is equal to 1, so if we solve this for z dot, we get z dot is equal to 1 divided by negative 1.5, which is negative 2/3, and because we know theta double dot is equal to 0, z double dot must be equal to 0. So we have z is equal to 6 when z is equal to 6 meters, z dot is equal to negative 2/3, z double dot is equal to 0. Plugging in 6 here, we get negative 9 for theta. We know theta dot is equal to 1 and theta double dot is equal to 0. Then plugging in 6 to our expression here, we get 4.5. Plugging in negative 2.3 to our expression here, we get negative 0.5. Plugging 0 in here, we get 0 for r double dot. So then the next step, which again I would like you to try on your own, is to find the radial, transverse, and z components of the acceleration, for which you can refer to equation 1232. So now find the radial, the transverse, and the z components of the acceleration, and we have r double dot minus r theta dot squared for the radial component, r times theta double dot plus 2 r dot theta dot for the transverse component, and z double dot for the z component. So go ahead and figure out what we have for those 3 quantities. Okay, so we have for the radial component negative 4.5. We have for the transverse component 0 plus 2 times negative 0.5, which is negative 1. And for the z component, we have 0. Then just like in the problem with the boy on the slide, which was problem 89, in addition to the force that the slide exerts on the boy, or in this case, the force that the track exerts on the roller coaster, we have a force of gravity pointing downwards. So I have the force of gravity is equal to m times g pointing downwards in the z direction. And I also have the force of that the track exerts on the roller coaster. So when I sum up the forces in the radial direction, I don't have to worry about the force of gravity. So this is the mass times the acceleration in the radial direction. So the radial component of the force that the track exerts on the car would just be the mass of the roller coaster cart times negative 4.5, which gives me negative 900 newtons, and the negative sign means it's pointing in the negative r direction. And then in the transverse direction, again, I don't have to worry about the force of gravity since that's just pointing straight downwards. So this is equal to the mass times the transverse component of the acceleration. So the transverse component of the force that the track exerts on the roller coaster cart is the mass of 200 times this component of the acceleration is negative 1. So that's negative 200 newtons, where the negative sign means it's pointed in the negative transverse direction. And then the acceleration in the z direction is equal to 0, but I have a component of the force that the track exerts on the cart pointing in the z direction, but I have the force of gravity acting downwards. So the z component of the force is equal to m times g. So that is 200 times 9.81, and that gives me 1,960 newtons, or 1.96 kilonewtons. And that concludes problem 99.